Equation 4, which is m y double prime plus by prime plus ky must be equal to external force, right? So let's start from mass, okay? Mass weighing is 8 pounds, which means your mass can be found by like this way, weight over the gravitational force, okay? Since this problem we use like pound and feet, so we're gonna use like a 32 pound per second square for your gravity, okay? And that is equal to mass weighing 8 pound over 32, which is equal to 1/4. And what about the spring coefficient? They can be found by the Hooke's rule, right? So what you're going to do is like mg, which is what mass weighing, is equal to kx, okay? So my mg is given by 8 pound. K times the stretching amount is 0.8 feet, right? My K is 8 over 0.8, which is 10. Okay, so we are almost ready. Okay, all this information, with all this information, we can update the differential equation. Okay, here we go. And I can write 1/4 y double prime plus b is given by 1, which is y prime, plus 10y is equal to my external force is 2 cosine of 2t. Is that okay? So for my convenience, let me multiply 4 on both sides to free your coefficient, leading coefficient, okay? Then this can be written by y double prime plus 4y prime plus 40y is equal to 8 cosine 2t. Okay, I with me so far. Okay, now we have to take care of this one. Okay, it is second order linear differential equation, which is non-homogeneous, right? So we have to start from the characteristic equation for corresponding homogeneous equation. Okay, there we go. It is r squared plus 4r plus 40 equals 0. Then we should use the quadratic formula. Then your r can be found by negative b plus and minus square root b squared minus 4ac over 2a. Let me simplify. Negative 4 plus and minus square root of negative 144 over 2, which is negative 4 plus and minus 12i over 4. Then simply we can write this one as, not 4, but 2. Negative 2 plus and minus 6i. Okay. Since my solution of characteristic equation has the real and imaginary part, my like fundamental set of solution will be exponential function part and trigger function part as well. Okay, so here we go. Is equal to c1 times e to the negative 2t times cosine 6t plus c2 times e to the negative 2t times, give me 1 second. Let me make this one a little bit lower. That's enough. Then we come back. Times sine 60. That's it. This is my like solution for corresponding homogeneous equation. Okay. Then now we have to talk about the particular solution for your right hand side. Okay. There we go. So as like we're going to use like an undetermined coefficient method. So as you can see, my right hand side is 8 times cosine 2t, right? Which means my particular solution must be the cosine 2t and sine 2t4, right? There we go. So let me define my particular solution as 8 times cosine 2t plus b times sine 2t. To use the undetermined coefficient method, we need y prime and y double prime, right? So yp prime is minus 2a sine 2t plus 2b cosine 2t, and yp double prime is equal to, excuse me, minus 4a cosine 2t and minus 4b sine 2t. Now we are ready. We're going to plug in all this y prime and y double prime into the differential equation. Then, there we go. My differential equation, which is y double prime plus 4y prime plus 40y is equal to 8 cosine 2t will be like this form. Let me write everything, okay? Negative 4a cosine 2t minus 4b sine 2t and plus 4 times y prime, which is negative 2a sine 2t plus 2b cosine of 2t and plus 40 of y, which is a cosine 2t plus b sine 2t must be equal to your right hand side, which is 8 cosine of 2t. Okay, are you with me so far? Now we have to like solve this equation, but it is just comparison between your left hand side and right hand side. That's what I keep talking. Okay, so what I'm going to do is like, since you have like okay, like on your left hand side, I'm going to get all the cosine term and sine term separately. Okay, let me use the red pen for your cosine term. I'm talking about this guy, and this guy. Okay, be careful about like we have coefficient for second and third term. Okay, then let me use the red pen for cosine part. Okay, let me write cosine 2t first. Then we need the big parentheses. From the first one is negative 4a. The second one is plus 8b and plus 40a. That's it, right? And what about sine? I'm talking about this guy, and this guy, okay? Plus sine 2t and in big parentheses minus 4b and then negative 8a. I have to be careful because it's really easy to make a mistake. But since this is not the a real-time class, so even like you find my mistake, like there's no way to tell me, right? I'm really so sad. So plus 40b must be equal to your right hand side. 8 cosine 2t, right? That's it. So now like we'll compare your left hand side and right hand side. Since you do not have like any sine term on your right hand side, and that's obvious, this part must be equal to 0. And cosine part must be equal to exactly 8. From this idea, we can set up the system, right? Here we go. Let me write the 0 term first, okay? Like with simplifying, it is minus 8a plus 36b must be equal to 0. The second one, 36a plus 8b must be equal to 8. We are here now, okay? So to solve this problem, there are two ways. We can do the, oh, before like doing like that one, like let me simplify, okay? By divide by 4 almost, 4 everywhere, okay? Then this can be simplified like this way. Negative 2a plus 9b is equal to 0, and 9a plus 2b is equal to, okay, it's much clearer, right? So we can do either way. We can do the elimination or substitution, okay? Let me do the elimination, okay? So I will multiply 9 for the first one, multiply 2 for the second one, okay? Then your first equation will be negative 18a plus 81b 0. Second one is 18a plus 4b is equal to 4 now, okay? Then we're gonna add up, then your a term will be gone. Then this will be 85b is equal to 4. Then I can say my b is 4 over 85, okay? By plugging back this v value into like anywhere, then we can easily find a as well. A is equal to 18 over 85. We're almost there, okay? So now I can conclude my particular solution, which is 18 over 85 cosine 2t plus 4 over 85 sine 2t, right? There we go. So now I can write that the general solution, okay? There we go. Yt, which must be yht plus ypt is equal to c1 e to the minus 2t times cosine 60 plus c2 e to the minus 2t times sine 60, and particular solution part, which is plus 18 over 85 cosine 2t plus 4 over 85 sine 2t. Okay, this is general solution part. Okay, but we are not done yet, because like in this problem we had a like initial condition as well. Okay, what was the first initial condition? Let me come back. Okay, look at that. We didn't take care of the initial condition yet, right? But like in the problem, whenever you encounter this kind of problem, you have to decide the initial condition first. Okay, so here we go. Like in the mass is set in motion from its equilibrium position, right? Which means y0 equal to 0, and they said no initial velocity. That means y prime 0 is also equal to 0. Okay, so let me try to use the first initial condition first. Okay, here we go. Let me scroll down all the way down. Here we go. Since y0 equal to 0, plug in 0 in there, then what is that? All the sine term will be 0, then we're going to have only cosine term. So it is c1 e to the 0 equal to 1 and cosine 0 equal to 1, and plus 18 over 85 must equal 0. Then we can conclude your c1 is equal to negative 18 over 85. Okay, then to decide like a c2, we need y prime. Okay, so let me write y prime. Here we go. Oh. Y prime is equal to, okay, what is that? It's a little bit complicated, but we can do it. Here we go. It is, where's my yt? There we go. Product rule, right? First of all, product rule. Let me make it a little bit smaller to see yt. There we go. It's yt, right? So by the product rule, negative 2 c1 e to the minus 2t cosine. Oh, give me 1 second. Before doing this one, let me plug in c1 first. It might be much easier, right? Yt is equal to negative 18 over 85 e to the minus 2t cosine 60 plus c2 e to the minus 2t sine 60 plus 18 over 85 cosine 2t plus 4 over 85 sine 2t, right? Then we need y prime, which is equal to, by the product rule, excuse me, 2 36 over 85 e to the minus 2t cosine 60 and minus, and it will be plus later. But let me do it at the same time. It is 108.85 e to the minus 2t times sine 60. I'm doing like chain at the same time. And now what about second term? Plus C2 and minus 2 C2 to the minus 2t times sine 6t and plus 6 C2 e to the minus 2t cosine 6t. And what about third term? And it is easy, right? Minus like 36.85 sine 2t and plus 8/85 cosine 2t, right? Now, y prime 0 equals 0 as well. Plug in 0 in there, then all the sine term is gone. Then we're gonna have one cosine term only. Then the first term is like e to the 0 equal to 1 as well. And 36/85, what you can get like from first one. Second one is gone, third one is gone, and fourth one is 6 C2, and the very last one is 8/85 must be equal to 0. We are here now, okay? Then a little bit more. 6 C2 is equal to 44 minus 44/85. Okay. Then finally, mass C2 is divided by 6 top and bottom. Negative 44/85 times 1/6. Then simplify a little bit before multiply something like that. And that is equal to negative 22/255. Okay, that's it. We found everything. Now, let me write my general solution, okay, with initial condition, okay? It is equal to minus 18/85 e to the minus 2t cosine 6t minus 22/255 e to the minus 2t times sine 6t and plus 18/85 cosine 2t plus 4/85 sine 2t. That's it. This is the final solution of this problem, okay? So, well, let's talk about a little bit more about this, okay? First of all, as you talked about it, look at the first and second term. Your sine and cosine is always between -1 and 1, and my exponential function part is with a negative power. What does that mean? Whenever t is increasing, this goes to 0 and 0. Does it make sense? So like finally, like first two term which came from the corresponding homogeneous equation will goes to 0. That's why we're gonna say it is transient solution. Okay, here we go. Just write it on here, okay? It will be fine. Okay, what about this part? Like even t is increasing, like it is still oscillating by the cosine and sine function. So this one is like a steady state solution, okay? That's it, okay? So how can you draw the graph of this one? So it's easy. Let me try to use the try to show my web browser. There we go. Can you see this one? So like there are a couple of like tools there. So let's try to find an online plotting. Okay. So which is famous? But there are a couple more that I'm familiar with, like Desmos. Okay, there we go. So what we're gonna do is we're gonna try to draw the like plot of this one. Okay. Excuse me. Y is equal to. Let me try to plot the general solution first. Okay. Minus 18 over 85 e to the minus 2x times, we need sine function, cosine function first, okay? Cosine function with 6x and minus 22 over 255 e to the minus 2x, and now we need sine function. It must be 6x as well. And then now let me try to type my like particular source part, okay? Plus 18 over 85, and it is cosine function. It is 2x now, and plus 4 over 85 sine function of 2x. Almost there, okay? So, okay, let me see. So this one, like, forget about your negative side, okay? We are interested about your positive side only, okay? Like that. You see? Like, as you can see in this graph, it is like, just oscillation like that, okay? But like at the beginning, it is a little bit different, right? What does that mean? Like at the, like, small t value, and it has some, like, shape, but it is really concerned with the, well, like that, but like after sometimes, like it is like, steady state, like, the mode, okay? So which is like later is continuing like with this one, okay? It's definitely like belong to like steady state part, okay? So let me try to plot the like transient torsion things, okay? How can I choose everything? Oh, okay, lucky. So let me try to copy this one. Can I? Yes, it works. It works. And then how can I copy? No? No? Oh, that's old way, old-fashioned way, okay? Let me paste it here. And then if I, oh, delete particular solution part, then we're gonna have like transient solution part only, right? There we go. So look at that. This green one is the like transient solution part, right? As you can see in this graph, at the beginning there is some effect, but like finally it looks like converts to the zero, right? That's why I said, okay, transient means like whenever t is increasing, that goes to 0. Because like, transient solution part includes like e to the minus t, right? So let me draw the steady state, okay? Steady state could be different at the beginning, but later, whenever your time is getting bigger, then that part will be exactly the same with the general solution part, right? So let's do it. There we go. For this time, let me erase the transient solution part, okay? And I'm gonna plot the steady state part only. There we go. That's it. So look at that. As you can see in this figure, this purple one is the the steady state. Okay. So at the beginning, it is totally different with the general solution, which is red one. But when time is getting bigger, you see, like red one. The like online homework for this section, it is too complicated. Okay, so like I believe as long as you understand this problem, that is fine. So I believe you had a really hard time to try to catch me up, like through this like online lecture, and that's enough. Okay, so like as long as you understand like this problem, it is fine. That's why I'm not gonna give any homework for this section. Okay, thank you.